Multiple regression works very much like simple linear regression. In the template, what we want to do is identify each of our x's here. Now this template is limited to two independent factors, or two x's and one y. So let's suppose we have time and temperature, and then perhaps we're predicting some kind of hardness. We lay our values in the yellow colored cells, and as with the other templates, there's a maximum of 1,000 data points you can put in here. Once we lay those in, then we can see what the plots look like. Now this is taking each of the x's, so in this case it's time and hardness, and then temperature and hardness, and you can see how those correlate. And then we calculate our statistics down here. The regression equation is identified here, so we've got 46.9 plus 0.098 times time plus 0.005 times the temperature, and that's going to give us our hardness. That gives us an R squared of 0.85, or an adjusted R squared of just a little under 0.45. Confidence level is selected here at 95%. And then if we like, we can use this model now based on the regression equation. We can use that to then make some prediction of some other the value of hardness based on a number of different values of either time or temperature. So let's say, for example, I wanted to know specifically what the hardness would be based on this prediction equation of a time of 75 and a temperature of 90. Hardness is 54.72. And then likewise, we can back into the values of time and temperature, again based on the regression equation, based on some value of hardness. So if I have a hardness of 32.5, if that's a target, let's say I wanted to try and hit, then the temperature would be 150.93 minus and minus 0.4583. Now they may not be practical given the factors that we're using, but I think generally you can get the point where we can set a target, and then we can move into different values of time and temperature. And then I didn't mention, but I'd like to do that now, up here, keep an eye on your variation inflation factors. Those should be under 10, ideally under 5. Here you can see that they're quite low. So this is an indication of multicollinearity, and keep an eye on those as you're working your way through the regression modeling. And that's it for multiple regression.